Welcome to our channel Biswanka's Math Exclusive. This is my part 1 video on topology. Now start with the power set. What is power set? Let X be a non-empty set, then the family of Px are all subsets of X, including empty set, is called the power set of X. Now see an example. Let X equals to 1, 2, 3, then its power set Px equals to 5x 1, 2, 3, 1, 2, 2, 3, 1, 3 contains 2 to the power n elements. Here n is equal to 3, so 2 to the power 3 equals to 8. Here is total 8 elements. Then what is topology? A subfamily tau of Px is called a topology of X if phi and x belongs to tau, union of two or more members of tau is a member of tau, and intersection of any two and more elements of tau is a member of tau. Phi and x belongs to tau, union belongs to tau, and intersection belongs to tau. See example. Let x equals to 1, 2, 3, then px equals to 5 x 1, 2, 3, 1, 2, 1, 3 and 2, 3. Let tau 1 equals to 5x. Now we are satisfying the conditions. Check the condition. 5x belongs to tau 1, phi union x equals to x belongs to tau 1, phi intersection x equals to phi belongs to tau 1. So tau 1 is a topology. Let tau 2 equals to phi 1 and x. Phi and x belongs to tau 2, phi union 1 equals to 1 belongs to tau 2, and 1 union x equals to x belongs to tau 2, phi union x equals to x belongs to tau 2, and phi union 1 union x equals to x belongs to tau 2. So this is also a topology. As this is also a topology as intersections also belongs to tau 2. See, phi intersection 1 equals to phi, 1 intersection x equals to 1, phi intersection 1 intersection x equals to phi, all these belongs to tau 2. So tau 2 is a topology. Check tau 3. Is tau 3 is a topology? Let tau 3 equals to phi 1, 2 and x. Phi and x belongs to tau 3. 1 union 2 equals to 1 to not belongs to tau 2. So tau 3 is not a topology. If one of any condition is not satisfied, then this tau is not a topology. Now check for tau 4. Tau 4 equals to phi 1, 2, 3 and x. This condition satisfied, this condition satisfied, and this condition is also satisfied. So tau 4 is a topology. Next, the types of topology. Number 1, discrete topology. For any non-empty set X, the power set Px satisfies all conditions of topology, then this topology is called discrete topology. Example, let x equals to abc, the power set of x is Px equals to phi x a b c ab bc ca equals to tau is a discrete topology. That is, all power set is a discrete topology. Number 2, indiscrete topology. For any non-empty set, the subset phi and x of the power set Px of x satisfy all the conditions of topology is called indiscrete topology. Let example x equals to abc and its power set Px equals to phi x a b c ab ac bc. Then tau equals to phi x is a indiscrete topology. Number 3, trivial topology. Both discrete and indiscrete topology is called trivial topology. That is, together T1 and T2, that is discrete and indiscrete topology, are called together trivial topology. Both are trivial topology. Number 4, co-finite topology. Let X be an infinite set and tau consist of empty set and those subsets A of X such that X minus A is a finite set. This types of topology is known as co-finite topology, also known as finite complement topology. Next, number 5, non-trivial topology. All topologies except trivial topology is called non-trivial topology. Let x equals to a and b, then px equals to phi x a and b, then tau 1 equals to phi x discrete, tau 2 equals to px discrete, phi x indiscrete, px discrete, and tau 3 equals to phi x and a non-trivial topology, and tau 4 equals to phi x b is also non-trivial topology. Usual topology or Euclidean topology. Let U is the collection of all open sets of real, that is open subset of R, then all elements of U satisfy the conditions of topology, is called usual topology and also known as standard topology. Example, let U is a collection of subfamily of R2 is the usual topology. Then co-countable topology. Let tau be a non-empty set and Y be a collection of subsets of X consisting of empty set phi and all these non-empty subsets of X whose complement are countable, then tau is a topology for X and is called co-countable topology. So what is co-countable topology? A topology which is consisting of empty set tau, phi and non-empty subsets of X whose complements are countable, then tau is a topology of co-countable topology. Next, right hand and left hand topology. The topology is generated by the family of intervals of the form open interval a infinity equals to x belongs to R and x greater than a is called right hand topology, and whereas the left hand topology is of the form minus infinity to a where x belongs to R and x less than a. Hope you understand. So here my topic is end. If you find this video is helpful for you, please like, share and subscribe our channel. Thank you.